Okay, let me take a little time to talk about Chapter 8 here. This video is designed to just kind of give you a synopsis of what you're supposed to know here and what you're supposed to learn from Chapter 8. It is not exhaustive. I'm not going to go into detail. You can read the chapter and pick up all the details and all the important information from each section. In Chapter 8, you'll notice that all the sections here are broken down, and you'll notice the terms over here. All these terms you should understand, you should know. So that's a good way to start to kind of focus on those terms to see if you understand everything in the chapter. Okay. Before you even read the chapter, you might want to come to this review page here and go over this with me using this video, and then read. So that will kind of give you a little bit of a preview of what you should understand, what you should get out of the chapter. Okay, this whole chapter is all about chemical bonds, and obviously those bonds are what are going to hold the atoms together. And the reason that bonds are even formed in the first place is to lower the total energy of the compound or molecule. Okay, they get to a lower energy position by combining. Aggregating just means forming a bond. You need to know the different types of chemical bonds. There's basically ionic and covalent, but it's not like all ionic, all covalent. A bond may have properties of both. So for example, if something is mostly covalent, but it also has a little bit of an unequal sharing of electrons, which is characteristic of ionic, then we say it's polar covalent. So that just means that bonds are not like 100% ionic or 100% covalent. There's going to be some nature of both of those maybe in a bond. And this formula down here is just showing you, if you're asked to, how to find what percent of the bond is ionic. Okay. In a previous chapter, you talked about electronegativity. You learned about that in your periodic table trends, and that comes up again as we're talking about bonds, because obviously bonds are formed because either electrons are shared or they're transferred. Or sorry, electrons are either shared covalently or they're transferred ionically, and that has to do with the electronegativity of the atoms that are coming together. So make sure you understand that and remind yourself about that from a previous chapter. The unequal sharing that we've talked about here results in what is called a dipole. So the dipole moment in a particular bond is going to result in that particular molecule being polar or nonpolar. Okay, if it has a dipole moment, possibly it could be a polar molecule if those dipole moments all contribute to an unequal sharing of electrons. Those dipole moments can cancel each other out, but you're going to be looking at how you would form a possible polar bond or polar molecule given the unequal sharing of electrons. Ionic bonding, you're going to focus on that, and you do need to know how an ionic bond is formed, and you need to know that when you form an ion, an anion is when you gain electrons, and that anion is actually going to be larger than the original atom that it is formed from. A cation is a positively charged ion. It's formed from losing electrons. It actually loses those electrons and becomes smaller. The radius of a cation is smaller than the original atom that it came from. Okay? Lattice energy is simply the energy usually released when these ions come together and form a bond or a compound of some type. Because they are attracted to each other, as we mentioned up here, they're going to end up losing energy, going to a lower energy position, and as a result, that's what lattice energy is. When you have ions that come together, pack themselves together to form that ionic solid, how much energy is released. Bond energy, if atoms are bonded together, it's going to take work to pull them apart. That's what bond energy is, the energy necessary to break a covalent bond. And the more shared pairs of electrons that you have, obviously the bond energy is going to increase. So if you have a single bond or a double bond or a triple bond, the bond energy is going to increase the more pairs of electrons are being shared. So the other important thing here is Lewis structures. You're going to learn how to draw and make these diagrams. They are crucial. They are important for you to understand the structure of a molecule. So you're going to follow the rules. All this talks about the rules for drawing Lewis structures, and that's going to lead you into then being able to predict the geometric shape of a molecule. This will tie into the Lewis structures, then will tie into what is called the VSEPR model. That stands for the valence shell electron pair repulsion. That model helps you understand how electrons are going to spread themselves out around the central atom and give that molecule shape, give it a certain structure. Okay? So you have to be really good at Lewis structures. You might want to take just a moment and look through these review questions, because these 10 review questions are ones that you should be able to answer after reading the chapter. So if you want to take some time and look at those before, and then that will kind of direct your reading as you're going through this and kind of cause you to think and contemplate on these ideas to see if you can answer those after you've read the chapter. Okay? So everything in this chapter is important. You can't leave anything out here. This, like many of the things in chemistry, all these things are going to be needed as you move into further chapters. So don't leave anything out. Make sure you understand all of these terms over here. And if you've got any questions, obviously you can ask me and shoot me an email or send me some type of message through Buzz, and let me know what you don't understand, and I'm happy to help you. Okay?